And then for our final talk of this session before the break, we have Colleen O'Brien for Teaching Programming with Tidyverse Koans, a journey of successes and failures. Oh no.
Great. Hi, everybody. My name is Colleen O'Brien. I'm an economics PhD student at the University of Oregon, and my specialty has sort of become teaching econometrics, especially using the Tidyverse. I've taught that course 7 different times in 7 different econometrics courses, and so my materials have really evolved over the past couple of years, and I've never presented them outside of the university, so I'm super, super excited to do that. So my broad vision for this talk is that in the modern world, software engineers are not the only people who program anymore. And so what that means is that computer scientists are not the only people who teach programming. Economists teach programming, all kinds of people do. And so what I've discovered in the past couple of years of teaching programming with the Tidyverse and R is that if you're tasked with something as difficult as that, what you have to discover are what koans are. And because I think that they are the absolute best place to start. And that's because they're gentle, they're self-paced, they're easy for you to create as a teacher. And I think you're gonna have really, really terrific results. So this, I went back a couple years and opened up my very first materials teaching R, and it was very humbling because I was also learning R at the same time. And so just like David said in his talk, my go-to strategy, I think, to kind of cover up how insecure I was about the whole process was to throw as much as I possibly could at these students and give them, for any given concept, I would give them at least 3 strategies to do it. So, reading in data, 3 functions from 3 different packages. I think I was just trying to distract from something. So that was my first mistake, just throwing as much as I possibly could at the students. And that's very, very counterproductive. This is in the first 10 minutes of my very first class teaching R. I said, go and open up RStudio and try all these functions. Again, just throwing as much as I possibly could at the students. And you notice none of these functions are from the Tidyverse. So that's another thing that I learned. You can really separate base R from the Tidyverse because they exist to do 2 very different things. Imperative programming to implement something like an algorithm from scratch, that's where you want to go for base R. But what I'm doing in my econometrics classes is we get some data, we answer some questions about it using dplyr, we plot it, we maybe run some regressions, and maybe we do some simulations to learn about the properties of our estimators. And you can do all of that in the Tidyverse. So I've mostly, I basically don't teach any of these functions anymore because there's, Tidyverse equivalents. Then the next thing, sorry, it's a little bit small, but the next thing I did was I taught a square bracket subsetting. Again, I abandoned everything from base R, so it was shocking to me looking back at this first course because the entire first day, I don't teach any of that stuff anymore. So it was just, surprising to me. So now when I'm working with a TA or something, and I sit them down and I describe my approach, I just tell them we're gonna avoid these 3 things, and it always shocks them. We're not gonna tell students about square brackets or the $sign, for extracting a vector from a tibble. We're not gonna tell them about for and if and while, because they belong in the base R imperative land, and we just don't need it in something like econometrics, or at least at the undergraduate level for econometrics. And then my very first class teaching R, I did a lot of live coding because I read that was the best strategy. I've also abandoned that. And I think it wasn't working for me because I wasn't getting real engagement. I was getting like a couple of students who would kind of play along, but most of the students fogged out, you know, and I was kind of losing them immediately when I was trying to do something like live coding. And I think what I've learned is that with live coding, if you're going to do it, I think you gotta focus on these 4 elements, and then maybe you can make it work. I couldn't, but I think engagement comes from tribe, expectations, rank, and autonomy. And tribe means, you know, I'm rooting for you. We're all on the same team. With live coding, at least how I was doing it, it was very much me at the keyboard versus you. I'm going to keep on asking you questions until you give me the answer I want. And so that's also a rank issue. You know, we were at 2 different levels. The expectations thing is, do the students know what to expect? And with something like live coding, they never know exactly what to expect because I'm always teaching something new, right? That's the point of getting up and teaching, is you're going to give students something that they don't necessarily expect. And if you surprise students, they don't feel safe or comfortable enough to really think and engage with you. And then autonomy is the last thing, which I think fails with live coding a lot of the time, because say a student wants to pursue some kind of line of thought, if it doesn't match what you want to do as a teacher, you're going to shut them down. You're not going to go down that rabbit hole with them, especially in front of a group of people, you know, because that can really derail you. So I think live coding can work, but you gotta focus on these 4 things. So now what I currently do is, instead of really lecturing or giving any instruction in person about teaching R, so I send them home with koans, which are little worksheets. I think I have it, yeah. So my current version, the first thing that they do is they sit down and try and do it themselves first before I give any kind of instruction. And what koans are there's Lisp koans, there's Ruby koans, there's Python koans, there's other R koans. I also have my koans up on GitHub, and you can talk to me about it if you want to, if you have questions about that. But these are all on GitHub. The very first thing I have them do is I have them learn about vectors. And so that's a really good like starting point to understand the tidyverse stuff, because everything's vectorized, right? So what koans are is they're just short, fill in the blank exercises with accompanying test files. So they go to GitHub, they download my package, and they can, so the very first question is, make the first element of this numeric vector a 6. So they just go down to the exercise, they delete the __, they replace it with a 6. I tell them what hotkeys to use to execute the command, and I tell them what hotkeys to use to run the test file. And then, you know, so they answer this first question, they run the test, and it says, you passed the first question. And so, yeah, so I think koans are strongest when the instructions are really clear and direct, and then they immediately get the gratification of a passing test. So the third question in this very first koan is to multiply a scalar and a vector. So I see a lot of R teaching materials, which are like, they start with like, R is a calculator. You can multiply 2 numbers in R. I don't even go, I just jump to, you can multiply a scalar with a vector, because that's something that maybe at least my undergraduate students wouldn't necessarily know how to do, like with a calculator or in the browser or something. So it immediately demonstrates that R has some value to them. And then I finish out the first koan with introducing some simple functions like sample, and it just demonstrates another source of value for R for the students, and reinforce it. So I show them how to randomly sample from a numeric vector, and then I quiz them about sampling from a character vector. So reinforces the things that I've already taught in this first koan. So this is the outline. I've made a set of 20 koans that take students from knowing nothing about R and programming I teach them about vectors. See, this scrolls. Here we go. So like the very first week, I have them do the first 3 vectors, tibbles, and pipes. Then I teach them about dplyr. Then by week 3 or 4, they're using ggplot2. We do some stats stuff because this is an econometrics course. Then I teach them how to write functions. And we end with map, some econometric stuff, and then reduce and accumulate. So for me, this is like kind of the main points of the whole Tidyverse ecosystem, and I guess, and everything that they need to start being able to do their own like econometrics projects. Again, these are all on GitHub. Use them, take a look, star my repo. Yeah, those are, so just so you know they work. The thing about these cones is that my students are obsessed with them. We finish the class and my students are asking me where to find more cones. So yeah, they really work. Then just this spring, I've worked on 2 kind of extra projects around the cones. I've recorded a couple of YouTube videos to introduce the cones, and basically just to emphasize, I love hotkeys. That's what I talk a lot about here. And then I also drew up a little zine because I think some of the concepts can just be a little bit more talking about the method is material. Forget. So some of the concepts can be a little bit easier to describe when it's in a more visual way. So I also have that on GitHub. And then, yeah, my final thoughts, advice for teaching R to undergrads, keep it as simple as possible. Don't overwhelm them with too many different ways to do a task. And then with cones, something really, really cool about cones is that test coverage becomes a fundamental first building block. They learn about tests the very first time they go and they start the cones. And so I think, in economics, at least, we've kind of embraced reproducibility, but something we haven't done so much is to embrace tests and validating our code. And I think especially as ChatGPT becomes a bigger thing, and people are using code that they don't necessarily understand, that they haven't written themselves, that could result in behavior that they don't anticipate. You've got to get used to having full test coverage for your code. I think that's going to be on the horizon for economics, at least. If you want to get serious about catching bugs in your code, you got to write tests. And then finally, last note is don't forget to tell your students that they're doing well. I think that's a kind of a gift as a teacher that you can give your students that really, really changes everything for a student. I like to, if I notice the students are using my hotkeys and they seem to be just doing well and catching on to things, I tell them, hey, you're really catching on to this. And I can see it just shifting everything for them. So that's it for me. Come and ask me questions about my cones, and give that star on GitHub to me.